see my screen that side?
Yes, sir.
You can. Oh, thank you. Oh, what an achievement. It's not easy, guys, to do these things. Technology sometimes. What do you guys see before I get excited? Can you see the piece of paper? Or my hand? Or the pen?
Yes, sir.
Oh, thank you. Okay, fine.
The pen.
Oh, thank you. Oh, not my hand, the pen. Thank you. Okay, cool. Remember, guys, let me start off by saying, remember, guys, for trusses, there's only two types of reactions that you're going to deal with. One is a pin support or pin support. This is a pin support. Okay. The other one is a roller support. Alright, I'll show a roller support somewhere there. That's how I show a roller support. Okay. This is a pin support. Okay. A pin support, regardless of the orientation, guys, a pin support will have a vertical reaction. I'm gonna show two arrows. That direction is going in the Y direction. Then it's got a horizontal reaction, which is X direction. Always. Whether it's orientated like this, so that reaction will have that, which is X, will have this, which is Y. Whether it's orientated upside down. So don't be intimidated by the orientation. We'll have Y and we'll have X. Whether it's pin support, always have two reactions. Then let's go to a roller support. This roller support is rolling. This is a horizontal roller. So roller support. So this is a horizontal roller. So it is rolling in this direction, horizontal. So in other words, you don't have a reaction in that direction. Where it's rolling horizontally, no reaction there. So your reaction is in this direction. Remember, your roller has got one reaction and your pin support has got two reactions. So in total, you will have three reactions in a structure. Cool? So this is Y. Then even if I take it upside down, guys, like this, again, don't be like, yo, what is happening now here? Only that. It's still a horizontal roller, but I've indicated it like this just to confuse you guys, because remember the aim here is to fail the students. Joking, guys. Remember, we're working for the same team, guys. The aim is not to fail you guys, is to support you, is to help you, is to transfer knowledge. If you think we're out to fail you guys, you're fighting the wrong person. Never fight lecturers. Lecturers are out there to help you. Yes, I know some of us can be very difficult, but maybe I'm one of those guys that are difficult. You'll never know. So, orientation is like this. So, this one is rolling in this direction. Therefore, you cannot have a reaction in this direction. Your reaction must be in the X direction. So, if you can have this knowledge now, so regardless of the structure, I'm thinking now, I'm trying to think what is in your tutorial question. I think one of the question is got a truss like this. Yes, I'm not gonna get it perfect, guys. Don't worry about that. One of the trusses is got a something like this. Then you've got a roller there. Then you've got a pin support, something like this. So all you All you know is that I have a reaction in this direction. I don't know that direction yet. I have a reaction in this direction. And I have a reaction in this direction. Three reactions. That's all. Do not panic. Do not panic. That is very, very crucial, guys, that you understand that. And then, going back to how do you go about solve problems like this in terms of now calculating reactions. So, the easy reaction, guys, remember, there's two there. There's two axes. Try not to start by solving those two. Those two. Start off by solving that reaction. That one, I don't know. I'm thinking about the easy way to say this to you guys so that you can understand it in English. The obvious one, the easy reaction to start off is this one because it's the only reaction there in that structure. So if you've got vertical forces, whether they're going or somewhere there, you've got an inclined force, you're gonna work out the perpendicular component and the vertical component. This force, that force, and that force must be resisted somewhere. Where is somewhere? Is there? Because they are all going in the vertical direction, and there's only one vertical reaction in that structure. Is there? Whereas, if you have a situation, what about these ones? I know, the only thing I know is that that force there must be resisted by this reaction and that reaction, but I don't know how these two reactions are going to share the force. Hence I'm saying you cannot start with these two reactions. Rather, you start with this one. This one will solve most of your problems. Because if, for example, you start with this one, as I say this, let me not say that. Okay, now, the question is now, what if the same I'm just throwing that one. Now I've got a horizontal roller. Then I've got so here you've got a reaction in this direction. You've got a reaction in this direction, and you've got a reaction in this direction. So you have two vertical reactions. So which reaction is easy for you? The horizontal reaction. Start off by saying, by solving that one, because it's easy. Because these two, they must share the loads that your external applied loads that are in that in that structure. They must share. How are they going to share? You don't know it yet. Before I go any further, guys, any questions there? Any questions, guys? Is that clear, guys? At least someone must say yes or no. Is that clear? Okay. Let me. Yes, but.
No, sir. Yeah, it's all right.
It's all right. Thank you. For that. We need feedback, guys. You need to, just like a church. You will hear the what the pastor is saying. You must say amen, amen. So I need that amen from you guys. Please, amen. Thank you. Okay, fine. The question is, guys, how do you go about solve these problems? Guys, don't make a mistake. Please, don't make a mistake of just saying, please. Sum of forces in the x direction equal to 0. Sum of forces in the y direction equal to 0. Sum of moments around the point must be equal. These are the three equations that you use to solve any problem in structures. Whether you are solving whether you're calculating reactions, whether you're solving internal forces using method of section, or you're solving internal forces using resolution of joints, or you're solving beams, or you're solving frames, anything, guys. By the way, even when calculating, when doing what you call this section properties, you're using these three equations. In most of for section properties, we're gonna use this a lot because we are taking moments about the bottom of the truss, or the top, or sorry, not the truss, the cross section, or the top of the cross section, or the left hand side or the right hand side. That is the first moment of area. And then you will do the same, but now doing the what? The second moment of area. But I don't want to go there. That is the topic for next week. Let's address that topic next week, because I want people to go now home with this energy that they're gonna have today, and then start working on these problems. By next week, they're asking questions and they're ready for the test. To be honest with you guys, it's easy for you to get 100% for this test. But is it about getting 100%? No, it's about the knowledge that you're gonna leave the university with. It's not about you've got a pass, you've got a fail. Even if you fail, if you're failing with the knowledge, that's good. But we don't want you to fail. Okay, cool. Now, remember I said to you, for this one, it's easy to start with this one. So meaning you're gonna use this equation. It's vertical, therefore I must use sum of forces in the vertical direction.
So why is it easy to start from that one?
Because it's the only reaction that is going up. So all the forces that are going up and down in the y direction, they must be resisted by this one. It's the only reaction. Whereas, whereas if you start with these two, yes, they are the horizontal reaction. You have a horizontal force there, but you don't know how these two reactions are going to share that. For example, let me explain it. If I'm going to say A, this one I'm going to say B. If you decide to use this sum of forces in the x direction, so you will have bx, and you will have ax as your unknown in one equation, because they both going in the x direction. So I'm using sum of forces in the x direction equal to 0. Then you will have your force. I'm going to call it Fx. You will have your Fx. This one is a known. You know the magnitude of this force. You know this one, but you don't know Ax. And you don't know Ay. Because they all going in the x direction. Because which equation I'm using? I'm using this equation that says sum of forces in the x direction must be equal to 0. So I must identify now which forces, including reactions, that are going in the x direction. This is going in the x direction, this is going in the x direction, and the force is going in the x direction. So this equation will have two unknowns, then you say equal to 0. It's going to have two unknowns in one equation, then you are stuck. I hope I've answered your question. Same applies here. If you start by calculating sum of verticals here, that is using this equation. If this is A, this is B, then you will have, obvious, this is y direction, this is y direction. So you're going to say AY, then you've got BY, because you are using sum of forces in the y direction equal to 0. You will have AY, you will have BY. If you've got a force there, then let's say PY, then you will have PY, then this one PY2, then you will have PY2. You know this, you know this. Do you know BY? No. Do you know AY? No. So you've got two unknowns in one equation. Therefore, you must box clever, guys. If you have a situation like this, check here. There's only one vertical reaction, therefore I must start by calculating vertical reaction. Here I've got only one horizontal reaction, therefore I must start by calculating horizontal reactions. I hope I've answered your question.
Yes, sir.
Happy?
Makes
So
sense.
that's cool. That's cool. Now, in terms of your assumption, guys, it's not important. Don't try and think I must assume it in such a way that, guys, you can just assume that this is going up, going left. It doesn't matter. Remember, if you assume this is going up, maybe this one is going down and this one is going down equal to 0. Solve that equation. I'm sorry, I've used the wrong equation. Solve the equation. Then if you're getting a negative answer, that means your assumption that this reaction is going up is incorrect. So the right direction is going down. That's why now you're going to say, when you're doing these problems, that no, you work out your solution, and then you arrived at an answer where you're going to say AY, I'm making an example, is equal to something kilonewtons. Then if that answer there is negative, you don't write the negative there. Instead, you change that direction. Remember, you got AY because you made that assumption that is going up. So your assumption is incorrect. The right assumption is AY is going down. Same applies with AX. If you assume that AX is going this side, but your calculation, you end up getting a negative answer, that means your assumption that BX, your assumption that BX is going to the left is incorrect. The right direction is going to the right. But don't stress now by trying to assume the answer that is going to give you the right direction. No, don't stress about that. Even when calculating resolution of choice, even when doing a resolution of choice, don't stress about, let me assume that is going this direction. No, just assume any direction. But you know that my assumption means this too, means this. So if I'm getting a positive answer, indeed, that reaction is going to the direction that I've assumed. Or if not, it's not going to the direction that I've assumed. Simple as that. That's why you will never hear me saying forces going up are negative, forces going down are positive, or whichever way, or forces going up are positive and forces going down are negative. You will never hear me saying that. To me, sign means nothing. For as long as I allocate the same signs to the forces that are going in the same direction. If I decide to say positive, these two, they're going to be negative because they're going down. But if I decide to say negative, these two must be positive because they go in the opposite direction to these two. Assign the same signs to the forces that are going in the same direction. Simple as that. Which sign is irrelevant, guys. Which side? So don't allow anyone who's going to come to you and say, oh, because it's going down it's negative. Please don't do that. Don't allow that. But if that assumption, if that is working for you, don't change it. If it's working for you, don't change it. Stick to that. It's working, then stick to that. Okay? So, any questions on, guys? I'm sorry, I don't know. Do you want me to solve a problem for you, or do you want me to address your issues? Because I might think that this method that I'm using here to just address this is good, only to find that to you it means nothing. You want to see values, but sometimes Values, they don't address everything that we need to address. They're just solving that problem. And then you go to the next problem. Then if you're lacking knowledge, then when you go to the next problem, then you're going to struggle because you're lacking the knowledge of or the concept how you must go about do these problems. Hence, I'm using this approach where I'm going to say, okay, fine, how do you go about do this?
So,
yes.
Could you do like an example of how you pick your values for bending movement? I know you can pick them from left or right, but
you're talking about. So I must take moments about a point here. Calculating a reaction.
Yes, sir.
Okay, cool. I'll do that. Okay, fine. I'll do that. So, what is asking, guys, is that Mazomba, you've addressed this. I'm happy. You've addressed this. I'm happy. Please address this for me. Sum of moments around a point must add up to 0. I hope I got your question right. Because here we were saying sum of horizontal, then I addressed that. Here we're saying sum of verticals, I addressed that. Now you want me to take moments about this. I'm going to take the same one. It's not going to be an example, guys, but it's going to be a what? Sort of. Let me just quickly draw this problem. Same problem as this one. Same problem. Let me just. Or you want me to do a problem that you were doing in class? Or sorry, not in class, man. That you did at home. Huh? Hello? Are you still there, guys?
Yes, sir.
Which one is that?
Can you do
sir?
the
Hello,
one
sir?
that we had to do at home?
Which one is that? Which one you did? You want me, or you want to pick a problem that you that is in your, what do you call this? Tutorial questions. I can do that as well. Let me just look for.
Maybe even the tests UDL, sir. The one with the triangle.
No. Wait. Now there's a problem. Remember, the test, the upcoming test. We said that the session is a question answer session on trusses. Is that right? So
Okay.
for a truss, I can't give you a truss that has got a uniformly distributed load. I can,
Okay.
but it's going to be a bit complicated for you. So the forces that you're going to deal with in a truss are point loads. If you look at my tutorial question, I've given you only point loads, not uniformly distributed loads. Is that right? So you won't have that. If you have those questions, I suggest that let's have a separate session. I can have a separate session with you where you will be asking about beams. Let's not include beams on today's sessions. On today's session, let's have a separate session where we'll have beams. Are you happy with that?
Okay, so
Sure. Let's do this. Let me try this one now. Let's say this height. Okay. Let's say this is any value, 50 kilonewtons. This one, at an angle of 30 degrees. Let's say this one is 45 kilonewtons. this distance is, let's say 1,2 meters, 1,2 meters. This one 2 meters. Let me just yeah. Okay, good. Truss this is A, this is B, this is C, this is D, this is E. Okay, let's try this one. Remember, guys, when you're doing this problem, I know students have got a tendency of trying to do complicated structures so that they can look good on the eyes of other students. That is your biggest mistake. Try and get the concept from a simple problem. Then from there, then you can start now attempting those tricky ones. But most of the time, if you go straight to the tricky ones, you're not going to achieve anything, because you're going to end up frustrated. You're going to end up saying, I don't know this thing. Then you're going to start blaming people. This guy doesn't know what he's talking about. Look, the book is saying this and all that stuff. You know the story. Only to find that you're the one who's approaching the section in a wrong way, or using the wrong approach. Okay, fine. Let's quickly do this one. So remember, first thing, identify your reactions. Here I've got a reaction in this direction. Here I've got a reaction in this direction, and I've got a reaction in this direction. Okay. So remember, I said it's easy. Bx is the easy one. Is that right? Okay. I'm assuming that direction. It might be wrong. I'm assuming that direction. So I call it Bx. So I'm saying sum of forces in the x direction equal to 0. I'm going to be a bit fast here. Okay. This has a vertical component going down. That vertical component is 45 sine of 30. And this is got a horizontal component going in that direction. Because if you resolve, the arrow is going down. So if you resolve it vertically, still the arrow is going to go down. If you resolve it horizontally, still the arrow is going to go this way. So the arrow in this case is the tip of the pen. It's the tip of my pen. Sorry, it's the tip of my pen. So if I'm resolving vertically, the arrow is still going down. If I'm resolving horizontally, the arrow is still going to the right. Are you happy with that? Sure. Let's carry on. So this one is 45 cos of 30. Cos of 30 is this angle, guys. 30 degrees is this angle here. Always use the angle to the horizontal, guys. When you're resolving the components of the force that is at an angle. Even when you're doing it in Linpro, you can't enter forces at an angle in Linpro. You must resolve those forces vertical and horizontal. Get the components of those forces before. Okay, fine. Why am I starting with this one? Because it's the only horizontal reaction. So Bx, then I'm saying there's a horizontal force, 45 cos of 30. That direction, guys, is not assumed. It's the right direction. It's the right horizontal direction of this force. Horizontal component of that is going this direction. I always show the direction on top there, guys. Then this force does not have a horizontal component. I cannot include it here because I am saying here I'm looking at sum of forces in the horizontal direction. That's why it's important to write that equation there so that you remember what you're doing. This force, I cannot include it anymore. I cannot include it. So the next force is that one. Bx going this way. Then do I have other horizontal forces? No. This must be equal to 0. What I normally do, that's what I do. I always make my unknown positive, regardless of which direction my unknown is going. I always make my unknown positive. Positive. Then if I'm saying this is positive, obviously this must be negative because it's going the opposite direction to that. Then this one is going to be negative. Therefore, bx is equal to, I take this to that side of the equal sign, then it becomes positive 45 cos of 30. Then bx is equal to, I'm sure someone has got it already, but I will do it myself, 45 cos 30. That means 45 cos 30, 38.97. Are you getting that? Kilonewtons. Going which direction? To the left. Why am I saying it's going to the left? Because I assumed it that is going to the left there. And I am getting a positive answer there. If you look there, if you solve that, I'm getting a positive answer. What is that positive answer telling me? It's telling me that my assumed direction is correct. And I show that direction. Simple as that. Now, next one. I am going to take moments. It's up to you. I'm going to take moments about A. Sum of moments at A equal to 0. So, I'm taking moments about A. Look at this force. The line of action, the line is going through A. So there is no perpendicular distance from where this force is acting to A. So this force is out of that equation. It's not going to be part of that. Look at this force. That is the line of action for this force. So the perpendicular distance is that distance to point A. The line of action is going there. So the perpendicular distance from the line of action of that force to A is that distance. It must be perpendicular, guys. So 50 kilonewton is part of my equation. This reaction is going through this force. So it's out. So AY is out. This is Y. BY, is it out? It's out. Then we have a problem. We have a problem. Then we have a problem. That means my orientation, this orientation is wrong. Because if I'm taking moments about this, I'm cancelling this too. Which is, and there's no other point that I can take moments about when it comes to this. So the orientation between these two reactions, this one I must change it to what? To a vertical roller. So please forgive me for that. I'm changing that now. We always check this, guys, because remember this one was a thumb suck. I'm changing that. So this is wrong. But at least you've got the concept. So here now, you've got two horizontal. You don't have that. You've got two horizontal, that horizontal and that horizontal, and one vertical. Then you're going to say sum of verticals. Let me continue with this problem. Let me continue with this problem. Okay. Sum of moments at A equal to 0. I'm continuing with that problem. So I'm taking moments about this. This reaction is out because the line of action is there at A. The line of action is there. So it's out. BX has got a perpendicular distance. So the line of action for BX is there. It's running there. So the perpendicular distance is 2 meters. So I can start off by saying BX times 2. And if you look at this, you look at BX is rotating it in which direction? Anti-clockwise. I go to 50. Perpendicular distance 50 times. What is the perpendicular distance from 50 to, there's a line of action for 50. From 50 to that is 1,2. And that 50 is rotating also in an anti-clockwise direction. Then I go to this force, this vertical force here. That force is 45 sine of 30. And the perpendicular distance from there to there is what? It's 2,4. And it's also rotating it in this direction. This one, the line of action for this one is going there, so it's out. So I'm done with my unknown, then equal to 0. What I did here, yes, in as much as there's two horizontal reactions, but I started off by calculating that. But in this case, you can use sum of verticals or sum of horizontal. In that case, you must take moments about a point, which is what I did here. I am taking moments about A. There's A there. Signs, I'm going to say this is plus. Remember, I said to you, I like to make my unknown positive. This is my unknown Bx. This one is going the same direction. Can you see? Because I showed those directions there. So it's easy for me. Oh, it's the same direction as that one, therefore it's also positive. This one is also positive. Then you say 2px. Then you solve this. 50 times, okay, sorry, let me start off. 45 sine 30 times 2.4 was 114 equal to 0. What am I going to ask for in the test? I'll leave a block here, an empty block. I expect to plug 2, and I'll leave a block there. Then I'll expect you to plug that value equal to 0. That is what you're going to get in the test. Okay? Now, take this to that side of the equal sign. It becomes negative. And then 2bx is equal to negative 114. You divide that by 2. Bx is equal to negative 114 divided by 2. Then equal to 57 kilonewton. Can you see I am not writing a negative answer? Yes, I know my answer is negative. But what is this negative answer telling me here? There's a negative answer there that I didn't write. What is this negative answer is telling me? It's telling me that I've assumed the wrong direction. The right direction is this one. That's the right direction. I've assumed the wrong direction. The right direction is that one. So I've solved Bx. So if I want to use now sum of horizontal, if I'm confident that my Bx is correct, I can say now sum of horizontal forces. Sum of forces in the x direction equal to 0. So I'm going to use my 57, which is my Bx. There's my Bx there. What is Bx? Is that reaction there. And did I use that direction? No. I used the right direction, which is the direction that I got here. Is the right direction. That one that you see there on the structure is not the right direction because it's an assumed direction. Okay, 57. Then I've got 45 cos of what? 45 cos of 30, which is this one. It's also going the horizontal direction. Then I've got my AX. There's my AX. I'm assuming that it's going to the left. Then I've got AX going to the left. Those are my only horizontal direction. Now, in this equation, I've got only one unknown because I solved the other unknown, but using sum of moments about A. My other unknown in the horizontal direction was Bx. I've already got my Bx. So, remember I said I always make my unknown positive. So this one is going this direction, therefore negative. This one negative, because it's opposite that. This must be equal to 0. Then AX negative, sorry. If you add the two, (95.97) equal to 0. Therefore, what is AX? AX is equal to 95.97 kilonewtons, and going to the left. Why? I assumed it here, that is going to the left, and I've got a positive answer. That means my assumption is indeed correct. The question is, can you check now? Can you say, can you add that and add your forces and that force and say you're correct? You can't. Why? Because you used this to get this answer. You can't. Unless you took moments about that point. You took moments about B to get AX. Then if you use that approach, then you are able to add your AX and your BX. And then you see if your AX and your BX combined are going to give you that. Because if you took moments about B, then you're calculating AX and you are not using BX in your equation, because your BX will be cancelled because it's going through there, and your BY is going to be cancelled because it's going through that. So this method that we used here, it's very risky, because you're using something that you're not sure whether it's correct to calculate another answer or another reaction, which is dangerous. But if this is correct, this is quick. If you're confident that this is correct, then it's quicker to get AX by just saying, okay, sum of vertical, sum of horizontal, and then you use that there. I hope I tried to do what, to use your example there, to address your question there, because I am taking moments now, whereas previously I was just saying sum of horizontal, sum of verticals. Then if you like, you can go back and say, okay, fine, there's only one vertical reaction there. Then I can say, please forgive me guys, I can say sum of forces in the vertical direction equal to 0. Then I can say, okay, BY, I'm assuming is going up, 50, going down, 45 sine of 30, going down, equal to 0. Those are the only forces going in the vertical direction. Plus, minus, BY minus 50 plus 45 sine of 30. 72,5 equal to 0. Therefore, BY is equal to 72,5 kilonewton, and indeed it is going up, because I assumed here that is going up. You can see there, I assumed it's going up, and I'm getting a positive answer. Then problem solved. You've got all your reactions now. You've got your BY, you've got your BX, which is there, and you've got your AX. Any questions, guys? No questions? Now, let's look at solving internal forces now. I'm solving internal forces for the very same truss. Guys, aren't you having other lectures? Aren't you having another lecture after this one, guys?
I think so.
Yeah?
No, so we don't have any other lectures.
Okay, I don't want to waste your time, man. I don't want to waste your time. 72,5.
So can I ask a question on reactions?
On reactions, eh?
Yes, sir.
I'll
I just need to know, is it possible to get maybe a negative answer for one reaction and then a positive answer for the other? And then when you add them up, they give you the same value as the value of downwards reaction. I don't know if I'm making sense.
Can you, is it possible?
Is it possible to get a negative answer for your reaction at A and then negative answer for your reaction at B? And then when you add them up, they give you when you check them, they give you a 0
for the equilibrium of forces.
Yes, sir.
Remember the negative answer. Remember again, I'm going to repeat myself. Negative answer means that the direction, it does not mean, it means nothing. Means that only means that the direction that you've assumed is incorrect. That's why here, if I can go back here I got a negative answer. This is negative, but did I put a negative answer? No. So to me a negative answer means nothing. So as long as you're gonna say, okay, this reaction is going this direction, this one is going the opposite direction, and then the force there at the top, I'm talking about this reaction is going on the right, this one is going on the left, but the force there is going on the right. So if you add this and this and this, it must give you 0. The sum of horizontal must give you 0. Let me do that for you. I'll quickly do that for you. Sum of H must be equal to 0, meaning I've got 45 cos of 30. Obviously, you are going to get 0. Going this direction, which force is 45 cos 30? Is this force here? Sorry about that. Is this force here? 45 cos 30. Then I'm going to add my reactions now. Then I've got this reaction, 57 going this way. Then I've got this reaction, 95.97 is going this direction. So what am I going to do here? I'll just decide which one I'm making positive. So if I decide I make this negative, this one must be positive. If I decide to make this positive, this one must be negative. And the answer that you must get here, it must be 0. So I'm going to say positive, positive, this must be negative. I'm sure you're going to get 0 here. Can someone double check that for me? Is that what you were asking? It's not. It's not.
I think I was doing that program 3, question 3. So I'm getting something here. I'm not sure.
I don't know whether I'm able to. Let me just mute my. Sorry. Where is my thing here? I just want to. No, I can't see this thing now. Okay, fine. I wanted to mute my. It's hiding somewhere now. Okay. I wanted to mute my. What do you call this thing? My mic, so that I can hear you, because I can't hear you properly.
Okay, so I was doing question 3 on tutorial operations. So it's giving me like I have to minus dy from ay to get x0. So I think I'm wrong. I have to do it again.
But after this session, I'm sure. After this session, now I'm sure you're gonna go back now to that problem that you were doing with a different understanding, and you'll be able to see what we've been talking about. I don't know whether it's a wrong approach to say that. Do you?
No, sir, you're right. I think I'm going to redo it again. It's a different approach now.
Yes. Okay. No, that's cool. Now, this is the problem. This is 50 kilonewtons. Okay. D, C, B, and then A, E. Or do you want me to stop for today and then next week I do forces? Because you still have up to, when are you writing the test? On the 18th. Instead of doing section properties, then I do member forces next week. Do you want me to do that, or do you want me to continue? I don't want to delay. Some of the guys are happy with reactions. They don't have any problem, so they wanted us to do resolution of jointing and method of section. So any suggestions, guys, from the floor?
Sir, could you please carry on next week, because some of us don't have enough data to go on.
Yes, I'm thinking about that as well. Remember, I'm using unlimited Wi-Fi, and you guys don't have enough data, and I don't want people to start leaving the meeting. And I'm thinking, because sometimes we can be very negative as people. Then I'm thinking that they're not interested, but they ran out of data. Okay, but let me quickly summarize this now. Okay, I won't take more than 5 minutes. Is that okay? Okay, cool. Let me quickly do this. Now, in the test, maybe I will ask you to solve these two forces using resolution of joints. So meaning I expect you to take this joint D. Joint D. I'm rushing now. Joint D. There's joint D. There's a force there. That is that. Remember, this force, guys, is this force here. 45 cos 30. And that one is 45 sin 30. This one. Don't be confused now. Where is 22,5 coming from? And then you've got this one, 22,5, and then 38,97. The angle, second function 10. Must I say 1 over 1.2? I don't know whether I'm right here. Let's say this angle here is 39,81. If it's wrong, guys, you can fix it at home. Let's say this angle is 39,81. This angle. You can work it out, guys, in case I've got it wrong, because I'm rushing now. Okay, this force here is F. F stands for force. FDC. That's an internal force now. That's an internal force now. FDC, because this is D, there is C. This force here is FDE. The assumption whether this force is compressing or is in tension is irrelevant, guys. I can assume anything, guys. I can assume anything. That's what I'm trying to say to you. I can assume anything. But remember now, whatever you've assumed, if you're getting a negative answer, your assumption is incorrect. So what I've assumed here, I've assumed that these two forces are in compression, because they're compressing this joint. They're in compression. They're compressing the joint. So the next question is, which problem? This force is going horizontal. This force has got a horizontal and a vertical component. So if I'm solving for horizontal component, I'm going to have two unknowns, because this is horizontal. This one is also got a horizontal component. So I'll have two unknowns. That, unfortunately, I can't do that because I won't be able to solve that problem. So the easy way there is to say sum of verticals. sum of forces in the vertical direction equal to 0. This force has got a vertical reaction. This force does not have a vertical reaction. By saying sum of verticals, I'm eliminating, in this case, I'm eliminating the number of unknowns in my equation. It's very important, guys, to remember that. Try to eliminate the number of unknowns when you are choosing which approach you use. It's very important that to talk to yourself, ask yourself, how many unknowns do I have if I do this? How many unknowns do I have if I do this? How do I eliminate these unknowns? Which is exactly what I was doing here. I'm saying you are horizontal, you are having a horizontal component. So if I'm saying sum of horizontal, that means I'm including you and I'm including you. Therefore I can't, because I will have two unknowns in one equation. Then I started off by saying, let me try sum of verticals. Then sum of verticals, 22,5 going down. This force FDC, sine of this angle here, 39,81, and is going down because the vertical component is going that direction as well. Remember the pen? Remember the pencil, if the arrow now is the pen again. If I resolve it vertical, it's going to do that. If I resolve it horizontal, it's going to do this. Then it's also going down. This must be equal to 0. So if I say positive, as I've been telling you guys that I always try to make my unknown positive, this must be positive as well because they go in the same direction. I take this to that side of the equal sign, then I'm left with sine 39,81. I'm stopping, guys, after this one. I'm working out what is that. So 0,64 FDC plus, I'm going to say 22,5 equal to 0. That's what I'm going to ask you for in the test. What is that? What is that? You will have a box before FDC. Then you will have the box, empty box there just to punch it. What is that? Then you say, okay, fine. I take this to that side of the equal sign. And FDC is equal to negative 22,5. Already is telling you that because this one is positive here. Take this. FDC is equal to negative 22,5 divided by 0,64. Then FDC is equal to divide by, that's my answer, is negative. But am I going to put a negative there? No. 35,16 kilonewtons. Sorry, 31,16 kilonewtons. But the question is now, remember now we're talking internal forces. Is that right? We're not going to say going down or going up. We've graduated from say reactions. We're talking about going down, going up, going left, going right. Remember forces, internal forces, we're talking about compression and tension. Is this force, remember it's negative. It's in your mind. I've got a negative answer here. I assumed that it's compressing. So that means my assumption that this force DC is in compression is wrong. The right one is tension. So it is in tension. Please don't say negative is tension. Please don't say that. I never said that. I said I assumed that it is in compression, but I'm getting a negative answer there. That means my assumption is incorrect. My assumption that this force is in compression is incorrect. The right assumption, that force is in tension. So it's going up. So I'm going to come and change it here now. It's going up. Why am I changing here? Because I'm still going to use this force to calculate this force. So I'm going to say now, sum of forces in the x direction equal to 0. Sorry about that. It's Q. Then I've got 38,97. Then I've got, this one is out because it's got no horizontal component. Then I've got this FDC. I've calculated FDC there. I've got 35,16 cos of 39,81. So it's going this direction. Remember that direction now. The right direction is that one. So if you resolve it, horizontal is doing this. Okay? This one is going this direction. You come to this one, I assume that is compression. Then I said FDC DE equal to 0. So my unknown, remember FDC is going this way. I like to make my unknown positive, therefore this one and that one is negative. Can you see signs to me means nothing, guys? Then I add the two, FDC DE, sorry, minus I hope it's correct, but even if it's incorrect, guys, negative 65,98. Even if it's incorrect, equal to, even if it's incorrect, guys, remember, correct it at home because I'm rushing. Again, in the test, I'm going to ask for this, I'm going to ask for that. I can even ask for this equation, which is why it's important that you guys solve these things. You must have a piece of paper where you're solving these things then, so that when I ask for a step, a certain step, you know that step, you know you've got the solution for that step. You just plug in whatever that is required. Then FDE is equal to 65,98 kilonewtons, and it's positive because I took it that side of the equal sign. What is the positive telling me? That the assumption that this member is in compression is correct. I think let's stop here, guys, for today. Any questions?
So could you send the drawings you did today on the group?
I'll definitely do that. I will upload it on because I've recorded it using Flashback, so I will upload it on Teams. I'll upload it on Teams, but under live lecture videos. I'll create another folder called live lecture videos,
Okay.
and then I'll upload it there. I hope it's recorded. Did you enjoy the lecture, guys? No, I guess it's a no.
Yes, sir.
No, I guess it's a no. I was gonna say no more lectures.
Help with a
Then.
few things, sir.
Yeah.
Yes, sir.
Yeah.
There's the drawing that you were showing us how to do frames on lympho.
Yeah.
There's the member force that you calculated for DE. I don't think I understand that. For DE.
For which?
For DE, yeah.
Yes.
There's a reaction going up, and then the other one is going down. But then you only took the reaction that's going up for that member force.
Okay, wait. Let's quickly go there. Okay. You're talking about this equation here.
No, the drawing that we were using when you were showing us how to do the frames on lympho, yeah, that drawing, not this one here.
From LinPro.
Yeah, that drawing that we were using.
Please do me a favor, né? I don't want to create confusion here. Please do me a favor. Take a picture of what you're doing. Send it to me via WhatsApp. Then we can discuss it off this on WhatsApp.
Okay, sir. Thank you.
Guys, that's it for today. Thank you very much for attending. Remember, we will have another lecture next week on Wednesday, same time. So tomorrow's lecture, I'm moving it to next week. Is that right? Happy? Sharp, guys. Thank you very much. Thank you for what? For joining. Thank you, guys. Cheers. Bye.
Thank you, sir. Bye.
Thank you, guys. Thank you.